students, and welcome again to today's lesson as we look at our Knec revision. And today we're going to be checking numerical analysis. So remember to subscribe, share, and also comment on how these lessons are being helpful to you. My name is Mr. Ngige, BSc Mathematics, very passionate in helping out with TVET in engineering mathematics. Now, given that xn is an approximation to the root of the equation x cubed minus alpha x minus 5 equals to 0, where alpha is a constant, we're supposed to show, the first question was asking that we show that x with the subscript of n plus 1, the best approximation for the next term of x is just given by this value. Now, so the solution to this, we know one thing: a better approximation using the Newton's Rapphson method is given by, so given by n plus 1 is given by xn minus f xn, that is the subscript, then f prime xn. But this means when you have a prime, it means the first derivative. So first of all, we have our equation, which is this equation here, so that this will be our fx, so that will be our fx, which will be x cubed minus alpha x minus 5. Then now we replace our value of x and we just put it with x with the subscript n. So we have f xn. So everything that has an x, you just put it with the subscript of what? Of n. So we shall have x n, then we have cubed alpha x n, then you have a constant what? A constant 5. Then find the first derivative of fxn, so fxn, so the first derivative. How do you do differentiation? Drop the power, reduce the power by what? By 1, so you drop 3. Then xn is going to be what? To be squared. Then here we have one value of x. We have a constant term, so this is x to the power 1, so you drop 1, just remain with what? Just remains with alpha. So therefore, you have alpha in our case here. So remember, this is to the power 1. Drop the power, reduce the power by 1, it becomes xn to the power 0. And anything to the power 0 is what? Is 1. So this term here will just remain to be 1. And when you differentiate a constant, you get what? You get 0. Now, replacing now everything here, we have our fxn and we have our f prime x of n. Now replacing this in this formula, so we have the better approximation of x n plus 1 is given by, so we have xn. Then subtract our fxn is this function here, so subtract. Then remember, always put that into bracket because it will affect what we have inside here. So subtract x cubed n, then minus alpha xn minus 5, so you have that term. Then over the first derivative, so first derivative of xn is given by this, so over 3xn, then we have square, then minus alpha. Now we can put this as a fraction, so this is the same as xn to the power 1. So finding the LCM of these two terms, 1 and this term here, so we shall find that the LCM is this term, right? So our xn plus 1. Now writing this over the LCM, so we know our LCM will be 3xn squared minus alpha. Then we know, so this is the LCM, so this will go here these times. So this multiplies with this and this multiplies with that. We can just make it as simple as that. So multiply this, the whole of this expression here, and multiply 1 with this expression. So we shall have xn, then multiply by 3xn squared minus alpha, right? Then 1 multiplies with the whole of this. But remember, we have a negative here. So, but we can just write it before expanding. So we have 1, but having a 1 here does not change anything in this expression. So minus 5. So you have that. Now expand this expression. So this one is given by xn, and we have xn squared. So it becomes what? 3xn cubed. Then this and this becomes minus alpha xn. Then open this bracket here, so we have minus xn cubed, right? Then we have a negative and a negative, so we have what? cubed, this one is cubed. So 3xn, which are 3xn cubed minus this, so you remain with 2. You can just say here we have 2xn cubed. Then we have a negative alpha xn, and we have a positive alpha xn. So this and this cancels to become 0. So what term do you remain with? You remain plus positive of 5. Then all over, then we have this, therefore xn squared minus alpha. And this is your better approximation for your xn plus what? Plus 1. So we have already shown the first part. Now let's see the second part. So number 2. So given that our first approximation x0 is given by 3, and then the second one, which is x1, is given by 3.1053. So you're supposed to determine the value of alpha. So remember, our best approximation for xn plus 1 was given by what? From the previous one, it was given by 2x cubed n plus 5 over 3xn squared. It was minus alpha. So therefore, you have gotten this. You have proven that this is the best approximation. Now, you've been given the first and the second values of x. So what do we know? When you have the first approximation, you always replace the value of the first approximation to get the second approximation. Then the second, the value you get, you use it again to get the third approximation, and so on and so forth. So therefore, now we've been given the value of x0, and we've been given the value of x1. So what do we mean? When you have the value of x1, for you to get the value of x1, which is 3.1053, you had used what? You had used 3 as your first approximation. So if our x1 is our value, where we have 0, if this is 0, then plus 1, which gives us our x1 in short. So we'll be saying our x1, the value for x1 was to be given by 2, then taking the value of x0 here, so it will be 3, then cubed, then plus 5, right? Then we have 3. Then our first approximation here was 3. So 3, then squared, then minus alpha. So this, when replacing your x0 in this equation, it will give you x1, right? But what do we know? We already have the value of x1. So you can already see, in short, what you shall be solving here is just we shall be doing a simple algebra. Our value for x1 is given, which is 3.1053. So now you can solve for this equation to find the value of what? The value of alpha. So expanding this, we shall have 3.1053 equals to, this is 27, 27 times 2 is 54, 54 plus 5 gives you 50, gives you 59, then all over, 3 squared is 9, 9 times 3 gives you 27, so you shall have 27 minus alpha. Now cross multiply, so you can say this one is a 1, cross this term and this term, this term and this term. So you shall have 3.1053, then you shall have 27 minus alpha gives you 50, should give you 59. Now remember this term opens up everything here, so you shall have 3.1053, then you multiply by 27, which gives you 83.8431, then minus this times that gives you 3.1053 alpha, right, equals to 59. So we take this term, the other side, so you can just say minus 59, which gives us negative of 24. So negative 3.1053 alpha gives you negative of 24.8431. So therefore, solving for the value of x, so you divide by negative of 3.1053 this side and also on the right hand side. So our value of alpha, therefore, given by negative 24.8431, then divide by negative 3.1053. So and that gives us 3.1053 that gives us our value as 8.000. So our value alpha will be given by 8. So therefore, now you can now write the best approximation. So you have the value of alpha. So the best approximation here, xn plus 1, therefore generally will be given by xn plus 1 given by 2x squared. These are cubed, sorry. Cubed. Then we shall have n, then plus 5 all over 3x n squared minus what? Minus 8. So we have our value for alpha. Now we use again, now since we have now the best approximation, we find the value of x. The best value of x, correct to how many decimal places? 3 decimal places. Now, we are not going to start from x0. We already have a value for x0, we already have value of x1. So we can go to x2, right? We have x2. So x2 here will be given by replacing the value of x1 in this expression now. So we shall have 2. So value of x1 was 3.1053. Then we do what? We cube that, then plus 5 all over 3.1053. Then you square, then you subtract 8. So let's find out what this gives us. So you have a term 3.1053 1053 brackets then cubed. So cubed, then times 2, then plus 5. That gives us 64.888 and 1. Then the lower side we have 3.1053. Then you square that, 53. Then square. We have that. Then you multiply by 3. Then you subtract 8. So you get 20.9287. Now dividing this term and this term, so we have 64.8881. Then divide by 20.9287. You get your value as 3. So this value here will be 3.1004. Now, remember what you're supposed to be doing. The correct answer for x will be gotten by getting a value of x which is repeating itself. So our x1 was 3.105. Now, in our case here, we shall have 3.10. When you round this one off, again, it is in 5. So we can check the last term and see that one gives us an answer. So we can check. Let's check now our x3. So our x3, replace the value of x2. So we shall have 3.1004. Then you cube that, then plus 5, then all over 3, then 3.1004, then you square that, then you subtract 8. Now the upper term gives you 3.1004, then that one cubed, then times 2, then plus 5 gives you 64, then gives you 64.605. 1, then the lower term gives you 3.1004, then we have squared, then multiply by 3, then subtract 8, then we have 20.8374. Now dividing these two, we shall have, so we have 64.6051, then divide by 20.8374. That gives us again 3.1004. Therefore, we can deduce and say the best approximation for the value of x that satisfies the equation that we had is 3.1004. Also, you can round off. This is just 3.3.10023 decimal place. Now we check the 2022 series. So we've been given the question that is you've been told xn is a better is an approximation for this expression here. This equation is an equation n equals to 0, where lambda now here is a constant. Okay, so you're supposed to show that this one indeed is the better approximation using the Newton-Raphson method. So solution. Now we can say the Newton-Raphson method of approximation is just given by that. Then you have xn minus f xn. Then you have the first derivative of the function with respect to xn. Now we can just state our function fx is this function, which is just given by x cubed plus alpha x minus 3. Now replacing our x and just putting a subscript here of n. So we have f xn equals to xn cubed minus lambda xn, this is positive, then minus 3. Now replacing we can find the first derivative first, the first derivative, which is given by, drop the power, reduce the power by 1. So you have 3xn, then square plus, now remember this term here will become 1. So we shall just remain with what? Just remain with lambda. So that is the first derivative. Now, replacing now all this into the equation, so we know our xn plus 1 is given by, so xn, so we have xn minus, now remember always to put a bracket, right? Remember always to put a bracket when writing the function of xn, so into bracket xn cubed plus lambda xn minus 3, right? Then the first derivative, this first derivative is this function here, so 3xn squared plus what? Plus lambda. Now putting this one over 1, you can find an LCM, so the LCM of this and this is just this function, right? Now we can just say this is the LCM and this one, so this one is the LCM, therefore, so we can just take and say xn plus 1 is given by, so our LCM is this term here. So we have 3xn squared plus lambda. Now this term multiplies with this and this term multiplies with that. So we shall have xn, then 3xn squared plus lambda. So we have that. Then remember subtract by. So 1 multiplied by this just remains the way it is. Remember we still have our bracket. We have not opened that. So cubed plus lambda xn, then you have minus 3. Now opening this bracket, we shall have, we have xn and we have xn squared here. So we will have 3xn what? Cubed. Then this takes this, you have plus lambda xn. Then this, we have minus xn cubed. Then negative, and here is a positive, so it becomes a what? A negative. So you can see the reason of having this bracketed is because these signs changes, right? Then you shall have lambda xn, then negative gives you what? A positive value, then all over 3xn squared plus lambda. Now collecting like terms, terms that are familiar, so we have a cube function here and we have another one, expression. So this minus this gives you what? 2xn cubed. Then we have a positive value here of lambda xn and we have a negative value of lambda xn. So this and this cancels to become 0. Then you remain with what? Positive 3 over 3xn squared plus lambda. This is your xn plus 1. So now the second part is now, so we have already proven that indeed this is a better approximation, alright? Now we have been told by taking your first approximation x0 to be 0.8 and your second, that is x1 to be 1.0265. Now you're supposed to find the value of lambda here, then you find the root to this equation. So now the solution. So we know when you find the first approximation, again you use the first approximation to get the second. You get the second, you use it to get the third. So we know one thing, xn plus 1 in our case here is given by this. So now, but now we have the value of x, so this value, we just write the second approximation. So our second approximation x1 will be given by 2, remember, then you have your value 0.8, then do what? You cube, then plus 3, then you have 3 xn, this one is has to be squared, so this one is squared, right, then plus, but we have our value for xn, sorry, so our xn value is 0.8, so we have 0.8, then squared, then plus lambda. So therefore, but we know the value of x1. So x1 was to be found by this. Now we don't know the value of lambda here. Now replace the value of x1 since it is already known. Now we have this one to be 1.0265. Now just expand at the numerator and denominator and find the values. So we shall have 0.8 cubed, then you multiply by 2, then you add 3. So it gives you, the numerator here will give you 4.024. Then the denominator, that is 0.8, then you square that, then you multiply by 3, which gives you 1.92 plus what? Plus lambda. So we have 1.0265 equals to 4.024, and you have 1.92, then plus lambda. Then cross multiply, so you can see this one is over 1. So this multiplies this multiplies with that. So we have 1.0265, then into brackets 1.92 plus lambda gives you 4.024. Now opening that bracket, this bracket here, so times 1.0265, we get 1.97, you can just say 09, then plus 1.0265 lambda equals to 4.02024. Now take this term to the right hand side, so we shall have 024. So taking this to this other side, so we shall have 1.0265 lambda gives you 2.05312. Now divide both sides by this constant here. So we divide by 1.0265 by 1.02665. So dividing that by 1.0265, so we get our answer as 2. So therefore our lambda value is given by 2. That is correct to 3 decimal places. So we now have the value of lambda. Now we can get the approximation. So now we can rewrite this statement here and just say now our better approximation is given by xn plus 1 equals to 2xn cubed, then plus 3 over 3x squared n, then plus. So our value of lambda is what? Our value of lambda is 2. Now we can now solve for the root, the exact root. So we'll continue replacing the values of the x that we're going to be getting until we find a value of x that is repeating itself. So we have the first one as 0.8, the second one is 1.0265. Now let's get the third one. So that is x. So we shall have x, then that is x1, now we have x2. So again, we replace now the value of x1 in this expression here, right? So we shall have 2, and we have 1.0265, then you do what? You cube that, then plus 3 over 3, then 1.0265, then you square, then plus what? Plus 2, that will x2. So you have 1.0265. Then you do what to that? You cube, then multiply by 2, then you add 3, which gives you will be 5.1632. Let's say you can say 33, 4 decimal places. Then the lower value, so you have 1.0265. Then you square that, then you multiply by 3, then you add 2. Then you add 2. This gives you 5.1611. Now dividing the two terms, so 5.1633, then divide by 5.1611. That gives us 1.0004. So we can also check the third one, the fourth one, to see if this value now is repeating itself. So we can just check our x3 to verify our answer. So we use this term now, 1.0004, then cubed plus 3 over 3, 1.0004, then square, then plus 2. So we shall have 1.000, so 1.0004, then that 1 to the power 3 gives you that, and multiply by 2, then you add 3, gives you 5.0024. Then this value, the lower value is 1.000, then 4, then you square that, then multiply by 3, then you add 2. So it gives you the same value, 5.0024. When you divide these two, it gives you what? 1.000. You can see now, our best approximation now for the value of x is just given by